Hey guys, our next talk will be how to set up an experimentation process by Lydia Monnington. So Lydia, most recently head of data analytics at Stewart, she designs data-driven solutions for key business challenges, including cost reduction and expansion strategies. With prior roles at Ocado, GHG SAT, and Meta, she has expertise in experimentation, forecasting, and customer segmentation. A maths graduate from Oxford, she also champions data access for charities, serving as a director of STEMITS and as a data ambassador for DataKind, supporting data science for social good. If you could all put your hands together for Lydia.
So, imagine you're at your desk on Monday and your boss comes to you and asks you to run an experiment. Do you feel ready? Today I'm going to tell you the story of when this happened to me, what I did well, what went less well so you can avoid my mistakes. Since that first experiment, I've had the honor of running experiments in a number of roles. And so as well as what happened in that first experiment, I'm going to give you my top tips and learnings since then so you can continue do the best experiments you can. My goal is at the end of this talk, you are confident running your first experiment. Experimentation is a really deep topic, so at the end of this presentation, I'm going to share a QR code which has links to the slides and also further reading so you continue your journey into experimentation. So firstly, why experiment? For me, the key thing with experimentation is it allows you to tell the difference. When you've made a change, it means you know the impact of the change you've made. You might make a change and be like, is it the change I've made or something else? To give you some really good intuition about this, imagine you run an ice cream shop. You've got your ice cream sales, it's looking pretty good, you love data, so you're measuring your ice cream sales every day. And then on June the 1st, you make a change. And you look at this graph and you think, I've made a change and I've increased my sales, excellent. But then you start to think, wait a second, June is the beginning of summer, it's getting warmer, people like to eat ice cream in summer, maybe it's due to that. And so you plot the temperature against that. And then you're looking at it and you're like, did I actually do anything at all? And so the big challenge, and I'm sure that you all have had this, is you're trying to understand what the change is, and you're looking at this and you're like, maybe it's very hard to disentangle. You could do some very sophisticated modeling, but experimentation gets you there much faster. So let's say you only showed your new sales idea or your new flavor to half of your customers. And that would allow you to see really clearly the impact of the change you've made. So here, an additional 10 orders per week. So let's talk about my first experiment. It was sending out a catalog. So to give you a sense, it looks a bit like this, courtesy of ChatGPT. So it was 100 pages, glossy, full color. The idea behind it was to show off the amazing range of products we sold. So beautiful photos of the products, letting all our customers understand what we sold so they would buy more. The way we sent it out was putting each catalog into a customer order when they placed their orders. That saved us time on shipping costs. So, what are the key steps to go through when running your experiment? Planning, experimental design, assigning test and control, putting your experiment live, tracking exposure, and calculating your results. And I'm going to take you through each of those. So firstly, planning. The first thing you really want to get clear with you and all your stakeholders and all your peers is, why are we running this experiment? The worst thing you can have happen is you get to the end of the experiment and you realize you set it up wrong because what you thought you were doing is not the same as what your stakeholder thought you were doing. So the goal here is to be really 100% aligned. For the catalog, we wanted the additional profit from people who received the catalog to be more than the cost of the catalog. So that was printing it, designing it, getting a professional photographer, sending it out. The second thing is to have a great hypothesis. So this is where you state really clearly, what are you testing in this experiment and how are you testing it? So I think there's 3 things that make a great hypothesis. It's specific. You're testing one thing really clearly, and it's really clear what you're testing. You know what your mechanism is for why you're testing it and why you think it's going to work. And you've got metrics to measure the outcome. So for the catalog, our hypothesis was customers who receive the catalog will know our range of products better and know how great they are, and so they'll increase their spend in the 3 months after they receive the catalogue. And then you want to be really clear on your metrics. Here we had the profit increase in the 3 months after we received the catalogue. This is so you can make sure you're tracking that and you have it at the start. So after your planning, you'll have a goal, you'll have a hypothesis, and you'll have metrics, and most importantly, you and everyone else involved in the experiment will agree on these 3 things. That's the key thing to have, the key alignment. So next, you want to do your experimental design. So the catalogue was expensive to print, so we could only print 10,000 copies. That was about, not all of our customer base at the time. The key question to think about is if you had to pick customers to give the catalogue to, who would you pick? I'm going to give you a couple of seconds to just think about who you would pick. So the way we thought about this and the way I did this was basically who spent the most currently. The thinking behind this was if you've got a customer who's spending £50 a month and getting them to spend an extra £50 is a super big ask. If they're spending £1,000 a month, they might quite easily spend an extra £50 a month because it's only a 5% increase. So that's kind of why we pick the top spending customers. The next question was, how big should this group be? We're sending out 10,000 catalogues in customer orders. So when you place an order, you'll get a catalogue. How big should the group be? I'm going to pause again for you to think about that briefly. So how many of you said 10,000? I don't know if you want to do a show of hands. Because this is what I thought as well. Only one person's admitting to saying 10,000, so you might have been ahead of me. So, yeah, I picked 10,000 in the test group. In week 1, we delivered 2,000 catalogues. Excellent. But by week 4, we'd only delivered 3,000, or 30%. And so for our 12-week experiment, we weren't going to ship them all out. Do you have a sense of why? I started to think about it, and I modeled what was going to happen. The way to think about this is, in the first week, everyone who placed an order who's in the test group gets an order. In the second week, it's only the people who didn't place an order last week. In the third week, it's only the people who didn't place an order in the first 2 weeks. So as you go through, the number of catalogues you sent out each week goes down and down and down. So 10% of my group, even though they were top spenders, had churned and were never going to place another order. So we could never send them a catalogue. So we didn't have enough. Another group of customers did order, but just not very often. So they weren't going to come back in the time of the experiment. So we were way short on the number of catalogues to send out. So I should have accounted this in my calculations, but I hadn't. So how did we fix it? Effectively, I modeled, knowing that this was the problem, I modeled out how many catalogues we needed to send out. So I created a larger test group, and I modeled the number of catalogues that would be delivered from that, looking at their historical orders. And I said, okay, are we above 10,000? If so, and just above, use that test group. If not, repeat the process until we have the right size of catalogue. So the key learning from this, which will come up in almost any experiment you run, is you can say you want all your customers or all your users to be in the test group, but they might never see it. The way to think about this is, let's say you're editing a page on your website, they just might not visit the web page in the time of your experiment. Or if it's a specific product page or a specific page on, say your Q&A, maybe only 10% of people visit that every month, even if they're on the website. So really thinking about who is visiting that page and how many exposures you're going to get is a really big thing to think about to get right, because otherwise you might calculate an experiment size that you think, I've got loads of users I can put in this, but actually you can't. So the next really important thing is statistical significance. Effectively, to get a significant result, your experiment will need to be a certain size, have a certain number of exposures. You know this is wrong if your graph looks like this. So if you've got a lovely uplift of like 40% here, but your error bars go below 0 and are really wide. If that happens, you can't actually conclude that this experiment has run one. Even though it looks like it probably has, you can't say that your test group is better. And so then you'd be in trouble. So how do you calculate this? The math is pretty complex, so I usually suggest using a calculator. And this is one of my favorites, and I'll talk a little bit about why. So when you're setting this up, leave the power and significance as it is, unless you want to start changing that and you've done some additional reading. Then you want to work out your baseline conversion rate. So this is from historical data, what is the rate of people doing things? So for example, if they're clicking a button, you're looking at your analytical data, you're saying, okay, in the last 6 months, on average, 20% of people click this button. That's what you're looking at. The next thing is your minimum detectable effects. So this really is, what is the expected uplift what is the uplift you expect from this experiment? And you might be sitting there thinking, I'm running an experiment to find out this question. I don't know it yet. And this is this is the thing that actually you tend to run into the most trouble with. So in practice, I've approached this 3 ways. The first is, if you're lucky enough to have run a number of experiments at your company, you've run similar experiments to this one, you can say, like, okay, when I change the button to green, we got a 10% uplift, so maybe when I change it to pink, we'll get a similar amount. So if you do that, you can take the increases you've seen in the past. In 95% of cases, you won't be able to do that. So the second option is to say, okay, we're running this experiment. What uplift do we need to see to actually ship it? You might say greater than 0, in which case you can't use this. But say for the catalog, we know we need an uplift in spend of 20%. So here we'd put 20%, because we know if it's not 20%, we're not going to ship it, so we don't mind. And the third and probably most common method is to do it backwards, by which I mean you can say, I know we have 2,000 visitors a week to this page. We're going to put half in test, half in control, and we're going to run it for 4 weeks. That gives us 4,000 exposures. So, and then you put that into the calculator and you adjust this value until you get 4,000 out, and this value might come out as 10%, and then you're like, great, happy. It might come out as 200%, in which case then you have to have a difficult conversation about whether we run this experiment at all, or we don't have enough power for it. So that's the ways I think about this. The final bit, and why I love this calculator in particular, is when you say a 10% increase on 20%, there are 2 ways you can interpret that, and people tend to mean different things and get confused. So you could say a 10% increase on 20% is 30%, because it's 20 plus 10. And some people mean that when they say a 10% increase. Other people mean 20% times 1.1, so up to 22%. And those numbers are super far apart. And so if you're using a calculator, and one person means the top and one person means the bottom, you're going to have a bad time when you get to the end. And this happens all the time. And so I love this because it gives this beautiful little image that makes it 100% clear what's going on. And that's why I always use this one rather than any of the others. So, experimental design. 3 things to think about. Who should be in the experiment? Like, what is the criteria you're using to select customers? How many exposures do you need for the test? You need to model that out. And how many exposures do you need to get experimental power? So step 3 is assigning test and control. So for experiments to work, the key thing to think about is what we're really trying to do is to say, if Bob saw our change and didn't see our change, what's the difference in his behavior? Sadly, we don't have a time machine, so we can't do that. So what we're trying to do is get 2 groups of users and compare them. And so we have to assume that before the experiment, before the thing we're showing them, they are identical and comparable. Usually, we do this by selecting randomly. There are other methods if you're not able to select randomly or if it doesn't work for you, but in general, selecting randomly will get you there. So for the catalog, we were not really there on selecting randomly, I'm going to be honest. So what we were using was the last digit of catalog number. So that is saying, you look at their customer number, you take the last digit, and we said, okay, if you're in the test group, if you're an odd number, and in the control group if you're an even number. So this customer number ends in 7, and so they're in the test group. Simple. But a recent experiment run by a different team had put all the users with numbers 1 to 5 in the test group, and all the numbers 6 to 0 in the control group. So going to do a little pause again. Does anyone have a sense of why this is going to cause a problem? Okay, is it this? Yeah. So sadly, 10 does not divide by 4. And so if we knew that someone was in the previous experiment, we know they have a 60% chance of being in our experiment. That might be fine, but let's say the previous experiment was somehow amazing and had doubled customer spend. Those additional 10% of people are going to be before we even start skewing our results. And so that's why one of the really important things is not to have interference between experiments, by which I mean, if you are in experiment A, I should know nothing about if you're experiment B. They need to be independent. And so when you're assigning users to an experiment, you want 3 features. The first is randomness. The second is they're mutually exclusive across experiments. And the third is deterministic. I've not talked about this yet, but this is about if you have a user, say Sally. Sally comes to your website on Monday. You show her the test group. Sally comes back to your website on Thursday, and you show her the control group. Then you have a problem. You don't know which groups to put her in. Her experience is really confused. Everything keeps changing every day. And so you want a function that's deterministic. You can log it in the warehouse and log every exposure, and then every time someone loads the web page, pull that. But it's a much slower experience and much more difficult to code. And obviously, if you have any issues with your logging, that can break. Having a deterministic function is much better. So how do you do this? One way is using a hash function. You want to take the user ID and join it in a string join with a unique experiment ID or a unique experiment name. And that means you get a random number out, but that is deterministic, but based on the user ID and the experiment ID. And that's one of the best ways of doing that. Cool. So assigning test and control, you need assignments that are random, mutually exclusive and deterministic, and you want to hash the string combination of user ID and experiment ID to achieve this. So next, you're putting your experiment live. Happy days. So for us, that meant we started sending the catalogs out, putting them in custom orders. I spent a lot of time with our warehouse team, making sure they could find the catalogs and deliver them. And so what we were doing is to do this, I gave the warehouse team a list of custom IDs who are in the test group, and they added to the warehouse system those customers they would place the catalogs in their orders. And for you, this could be a whole range of different things. So you're probably going to be working with your software engineering team to add the experiment to your tooling or to change the code. They might need to have a switch statement to show the 2 different versions, putting that all in. There obviously are a lot of tools like Optimizely and StatSig that do this as well. So 5th, we're going to track exposures. So hopefully you've got a good enough logging that you know what customers have got in their orders. So we were tracking every customer, their customer ID, and what date they'd got the catalog. And so we said getting the catalog was the same as being exposed to the experiment, because you expect your behavior to change after that. And our goal is to know not just the control group, not just the test group, but the control group as well. So what's their group and what's their exposure date? But right now, we don't know what the group is for the control group. So how do we find those values for the control group? I put dates in here, but we don't actually have them yet. The first question is, could we just take the first day of the experiment and say all the control group were exposed on that day? Sadly, you can't do that, and I'm going to give you some intuition as to why. I'm going to simplify the world and say we've got 2 groups of customers, half order weekly and half order monthly. So after 2 weeks, all the weekly customers have a catalog, so they order every week, but only half the monthly customers do, because they're only the ones who order in week 1 and week 2. And so if we want to calculate how many orders we get per month, nothing to do with what's changed for the catalog, but just these 2 groups, we can do a little calculation. For the customers with the catalog, 50 order weekly, they all have catalogs, and so that's 50 customers with 4 orders per month. 50 order monthly, but only half have catalogs, so that's 25 customers with 1 order per month. And so of that, the average is 3 orders per month, and I've got the maths down there if you want to see it. But for the control group, we've just taken everyone, and so that's half with 4 orders a month and half with 1 order per month. So that's only 2.5 orders per month. And so even before we've started the experiment, I might say, we've uplifted sales by 20%. And that would be a complete lie, because this is just a wrong exposure. And so that would not be good at all. So we can't do that. So what we need to do is create synthetic exposures. So here we want to say, if the catalog was in the test, if the user was in the test group, when would they have got the catalog? So to do this, we want to take the first order after the experiment start for those customers, so these pink dots here. And so I'm going to give you a little bit of SQL for how to do that. And when you came to my talk last, you'll recognize the format. But basically what you want to say is, look at all your customers in the control group, their first order after the experiment start date, and then you're taking the customer ID and the minimum order date to get their exposure date. And those are your synthetic exposures. The key learning here is that this is actually a really, really big problem. The most annoying thing that can happen when this goes wrong is you've run your experiment for 4 weeks, or maybe 8 weeks, and you realize you've made a mistake, and there's no way to fix it, and you have to start again. And this has happened to me, and I was not happy. And the software engineer who I was working with was not happy either. And I'll give you some other examples of when this has gone wrong. One thing that's happened to me in the past is we'd made a change to the website, and it was just a little bit of code that needed to run. And 1% of the time, that code would fail. And when it failed, that user was not logged into the test group. And so that test group was then not quite comparable to the control group, because the control group didn't have this piece of code, because they were control group, and so it always logged. And that was enough to make the experiment not comparable and not work. And so the way to avoid this is from day one, track your exposures. And if you start seeing that they're not quite aligned, then you know something has gone wrong, and you want to investigate as soon as possible to avoid that. Because, this is incredibly painful when it happens and incredibly annoying. So, tracking exposures. Track exposures from the test group accurately. Make sure you've got comparable control group exposures. And from the start of the experiment, make sure you're monitoring to detect any issues. So finally, you're at the final step, calculating results. So first I'm going to just say there's 2 schools of thought on calculating experimental results and experimental power, frequentist and Bayesian. Today, because we've got 10 minutes, I'm going to talk about the frequentist approach. Bayesian approaches are better in a number of cases, and in the reading links at the end, I'll share, there's some articles where someone's written up how they've done Bayesian experimentation. There's some Bayesian calculators as well. So if you prefer that, or you want to look into that more, that is available to you. So our goal is to get a result of our change in spend and our confidence interval. So from what we've done so far, we have customer ID, if they're in test or control, and the date they were exposed to the experiment. And we also have an order table of customer ID, order, and order value. So you see in the order table, each customer appears multiple times with all the orders they've had. And so what we want, the first step we want to do, is create a table with the metrics for each customer. So what's the customer ID? Are they in test or control? What's their exposure date? And what's their total spend in 3 months after exposure? So you're doing that aggregation. And so how to do that in SQL. Apologies for those of you who have to look over other people's heads. So what you want to do is take your experimental exposures. You're doing an outer join to order details because even if someone's placed 0 orders since the experiment, we still want to look at those customers and just say they have a spend of 0. Otherwise, it would bias it. And then we're joining on customer ID and order date between what we're looking at. So here, exposure date and 3 months after the exposure date. And then we're taking everything from the exposures table and summing the order value. I'm also coalescing here again because those customers who have no orders, because we want a 0 value for them. So from that, we can calculate mean and standard deviation. I'm not going to tell you how to do that, but whatever tool you're using, SQL, Python, R, Excel, you'll figure it out. And then you want to calculate the change in the mean. Here we've got 130 over 100, so that's a 30% increase. And then you want to calculate your confidence intervals. This is where things get a little bit more fun. So you've got your difference between means. We know that's 30%. You've got your Z-score, which comes from the normal distribution. So that's 1.96 if you're doing a 2-tailed test at 95% confidence. And then you need your standard error of the difference between our values. And so that needs its own slide. And so you take your standard deviation of the test group, squared, over your test group exposures, standard deviation of the control group squared over the control group exposures. And then, so putting our values in, that we've got 10 squared, that was our standard deviation, over 10,000, 9 plus 9 squared over 10,000, square rooted, which gives us, right at the bottom here, 0.13. And if you want to test that on your calculators, you can. And then to calculate our confidence interval, it's 30% plus or minus 1.96 times that, which is 30% plus or minus 0.26. So now we have our confidence interval out. And so that means we've now got our result of change of spend 30% and between 29.74 and 30.26. So what did that mean for the catalogue? It meant it was profitable. And so we started sending it out every 6 months. And it was really good for the company, both in terms of sales from customers and also from our suppliers, because they were super happy about increasing their sales and also getting more brand recognition with our customers. So for calculating results, you want to calculate your customer metric table, calculate your mean and standard deviation, calculate your change in means, and calculate your confidence intervals. And so we are done. We've gone through the 6 steps: planning, experimental design, assigning tested control, putting your experiment live, tracking exposure, and calculating results. So what experiment are you most excited to run? Thank you very much.
Do we have any questions? Just put your hand up.
Everyone's now going to scan the QR code.
Hi, Lydia. Thank you for the interesting presentation. I was trying to get my head around with the initial sample selection. So you said you selected the group with the top spending. So when you do that, so I was thinking, don't you introduce a kind of a sampling bias, because the lowest spending group, I was thinking maybe more likely to have converted and just increase their uplift. So yeah, I was thinking about that.
So if I wanted to know how much say we wanted to know not just make the most amount of money, but wanted to run an experiment to know for the whole of our customer base, how much would it impact it? Then yes, 100%. But for what I was doing, which was just trying to make the most money, it made sense because we were never going to send it out to everyone. But I would never say, oh, if we send out this catalogue to the bottom percent of spenders, we'd expect them to spend 30% more. So I couldn't say that from what I've done.
Okay, thank you.
And if that doesn't make sense, we could chat afterwards.
Thank you for the talk, really useful.
No worries.
I do have a slightly more challenging questions. So just to put that into context, I'm working for helping teenagers to learn a bit more about personal finance, and I'm kind of thinking sort of like using some experimental design for this kind of program. But the problem is teenagers, you can only know if they're doing financially better when they sort of like graduate and come out to the sort of like the other worlds. So with that sort of like longevity and also so many factors that is beyond your control, how would you set up some sort of like experiment to kind of like track the success of the implementation?
Yeah, I mean,
Sorry,
ironically, no, it's a great question. And it's really, so the other thing I've been doing recently is, as was mentioned at the start, I do some work with DataKind, and currently one of the charities we're working with is a charity that works with young people to give them job training, and have exactly the same question, basically. Like, the thing you'd really want to do is get a bunch of people to apply and only accept half of them, and then make them all fill out forms 12 months or 5 years later and tell you how they're doing, but they probably would not be very, very keen on that. Yeah. So yeah, that would be the, like, if I was like able to wave a magic wand and say this is the experiment I want to run, that's what I would do. But the reality is, I suspect the people you don't help will never fill in the survey. So what we've been doing at DataKind is looking at, can we create a synthetic control? So, I was saying randomness is ideal, but sometimes you can't do it. So we're looking at things like, this is the group we've worked with, and we know their outcomes, but can we say, like, okay, these groups went to these schools, they had this deprivation, maybe they're on the free school meals, they were, had this gender, all these other things. Yeah, and basically you're trying to say, like, these are the people who were comparable to the people I picked, and how did they do? But it's deeply imperfect. So it's a really interesting but a really difficult question.
Yeah, yeah. Ideally, we're in an ideal world, but we're
Yeah.
not. So,
Yeah.
yeah.
Yeah, thanks for that talk. This isn't so much of a technical question, but more about like, obviously, when this is more from the perspective of working with people, setting up an experiment. So just some context. So me and my friends run a YouTube channel, and YouTube have recently rolled out a feature called Test and Compare.
Ooh.
So you can test basically thumbnails, and they set it up for you and everything. That's great. But what I've found from experience is that people, I don't want to say people without a data background, but people that haven't had the experience of doing an experiment, once you set it up, they then have this tendency of, instead of giving it, let's say, 14 days, a month, or how long you want to test it for, they're eager to jump to the results immediately. And so I was just curious if you've ever had that experience yourself and what you'd sort of advise to do in those situations.
100%. I think that's one of the... I was considering talking about that here, but I took it out. Yeah, and there's... I think it's very hard, basically, because what will happen is you can, sometimes the graph will change, sometimes you get novelty effects. Novelty effects, actually, I didn't talk about, but it's probably the easiest thing to talk about in that scenario of, like, often people, if you change something, will click on it just because it's different. And so in that sense, like, you should never stop an experiment in the first week or so just because of that. But then talking about the power, if it looks statistically significant, but you said, okay, we need to run it another 2 weeks, that's a much harder conversation. I don't have a great way of communicating that to people, I'll be honest. Like, there's so much good research, and actually, one of the really interesting things about the Bayesian approach is you can sometimes allow you to do early stopping successfully. One of the things you can do is, like, maybe pre-agree, we will look every week, and if it's static at that point, and then you can change, can do 99% instead of 95%, and that then is acceptable statistically as well. So there's some approaches you can take if you know ahead of time that you're going to have that problem. But yeah, it's a really big challenge.
Any more questions?
Cool.
Yeah. If we're done with questions, I think we'll stop. Give you 9 minutes back.
Awesome.
Yeah. Thank you very much.
Thank you very much.
Cheers.
Thank you.